Alright, what I told you in the beginning of class was a lot of times I get questions for tests straight off of warm-ups, so please make sure you understand this warm-up. Also, I was looking at the test, and a lot of the answer choices are written in standard form, which is what I asked you to do with number 1. You see what I'm talking about? Okay, you guys are being recorded, yes. Now, number 1, I wanted you to be parallel to this line. And how did I make it tricky? I put it in standard form. So you've got to put it in slope intercept form. So that would be 2y equals negative 6x plus 12. Divide everything by 2. What's the slope of this line? Now, I want to be parallel. So what slope do I need to use then? Negative 3, because parallel lines have the same slope. What if I had told you to be perpendicular to it, though? It'd be positive 1/3. But I told you to be parallel, so we're going to use m equals negative 3. And I went ahead and told you the y-intercept should be negative 6. So we're ready to at least write one form of the equation. Y equals negative 3x minus 6. Now, look what I asked for, though. Standard form. And I'm telling you, on the test on Friday, a lot of the answer choices are, because some of it's multiple choice, and a lot of times they put those answer choices in standard form. So really, this one's not that hard. Just move the x over. 3x plus y equals negative 6. Now, I told you they usually force the x to be negative. What if that's not true? To be positive. What if that's not true? What's another way this could look? Negative 3x minus y equals positive 6. Just change all the signs. Either one they wouldn't have them both because they're both correct, but they could have one or the other of those. You have got to be prepared for that. All right, number 2, I was asking you what is the relationship between these two graphs. Well, one's in standard form and one's in slope-intercept form. So what should you probably do first? Put them in slope-intercept form. I would prefer that instead of converting this to standard form, because in slope-intercept form you can tell things like what is the slope and what is the y-intercept. So let's convert this thing. 3y equals negative 5x plus 12. Divide everything by 3. Y equals negative 5/3 x plus 4. Did you guys notice a relationship between these two lines? They're perpendicular. Some kids told me they had the same y-intercept. They did not have the same y-intercept. Close. One was positive 4, but the other one was negative 4. And if you still didn't recognize that they're perpendicular, if you didn't look closely at their slopes and see what happened there, graph them. They should look perpendicular in your graph. It's not going to be perfect because the screen of your calculator is not perfect, but you should know about opposite reciprocal slopes. Those lines have to be perpendicular to each other. That's the answer I was looking for there. All right, we're going to hold off on going over the quiz and grading homework because I want to go over the lesson for today and explain to you what you're going to do for your homework. Now, unfortunately, if you're watching this video at home, I don't have a copy of the questions. You're going to have this linear functions worksheet in front of you. There's 3 situations, and they are all very similar situations. The reason is I used to split this up into groups, and everybody would do a different problem. So we're going to do one together, and then the one you're going to do for homework, it's almost identical. It's just going to have different numbers. All right, so do you see the first one about John? Read that to yourself, please. To yourself. Okay, obviously I didn't write the whole situation, but I wrote down the 2 important things that are going to help us answer every single question. At the bottom of the page, I have a list of things I want you to provide me with. I should have numbered them. I don't know why I didn't. So number them for me right now. Like number 1 is we're going to talk about what's independent in this problem. Number 2, we're going to talk about what's dependent. You see what I'm talking about at the bottom here? Number these things. Number 3 is the function rule. Number 4, you're going to give me a table of values. Number 5, you're going to tell me the slope and what it means. You see what I'm talking about? We got 9 things we're going to do. Now, I definitely shortened this problem, but John, what's John doing? He's driving home from a football game. And the only 2 pieces of information I gave you was that he's 18 miles from home after driving for 12 minutes, and then after driving for 20 minutes, he was 12 miles from home. We have got to convert those into points, and we have to put them in the right order. So you really have to think about here, what is independent and what is dependent? What's independent here? The time. When you're dealing with linear situations and time is involved, I hate to use the word always, but most of the time, now I'm talking about linear situations, time is usually going to be independent. What's dependent? The miles. Okay, and time in minutes. I do want you to be specific. What's dependent is distance, and it's specifically in miles. Okay, and that makes sense if you think about it. He's driving home, and the distance he is from home depends on how many minutes he's been driving, how long he's been driving. Eventually, what's going to happen? Eventually, he's going to get home and hopefully stop driving. He won't go through the house. Now, the 2 points or the 2 pieces of information that I gave you then, what order should they be in? Like, what's the first point I gave you? Exactly. It should be 12:18. Just because I gave you the number 18 miles first doesn't mean that's the X number. This is actually the Y number. That's the dependent. And this is the X value that goes with it. What's the other point I gave you? 2012. Okay, because you're inputting time values and you're getting back distance from home values. So literally what this means, he's been driving 12 minutes, now he's 18 miles from home. If he drives for 20 total minutes, how far is he from home? 12. Okay, now, we already kind of answered the first 2. This is what I'm looking for on the numbered things at the bottom, the things that you just numbered for me. This is what I'm looking for. The first thing I asked you for is to tell me what is the independent variable. Do not tell me X. Yes, X is always independent. What I'm asking here is what do the X's stand for in this problem? Time. The independent variable is time, and it's specifically in minutes. So that's the answer to number 1. What is the independent variable? Time, in minutes. Number 2, I'm asking you, what's the dependent variable? Distance. What are the Y values, in other words? So please don't just tell me Y values. You need to tell me specifically what the Y values in this problem mean, and they mean miles. Now, number 3 is asking you for a function rule. I didn't give you a function rule. Did I give you enough information to make a function rule? Absolutely. I gave you 2 points on a function. I really need you to know how to get the calculator to do this for you. Where do I go? Stat, edit, stat, calculate. Do that, please. I mean, yes, you can do it manually with your brain and your pencil and your paper. And I expect you to be able to do that. But we got to have good calculator skills as well. Yeah. And if we know points, but not an equation, the easiest thing to do is go to stat, edit, stat, calculate. Please make sure that you got L1 and L2, because it would be a shame to mess this up just because you punched something in wrong. 12:18 and 20:12. And then what do I do? Stat again. I already edited. Now I want to calculate. And I already told you this is a line. So we're going to go down to the linear regression and we're going to press enter a whole bunch of times until it tells us the equation. So what would we write for the equation? Now, they probably won't have a decimal. Y equals what? Negative 3/4 x plus 27. Now, please listen to me. I would not count that wrong, but I want everybody to look up here. I would prefer you to at least try to do it more like a function notation that they would do on the end of course exam. They probably wouldn't use x and y. At the very least, they'd probably use distance and time. So how would it look if we use distance and time? D, instead of y, they would say D, because y stand for what? Distance, equals negative 3/4 t for time. They might use m for minutes. Sometimes they don't use m because m is what we usually use for slope. Plus 27. Or they might use function notation like this. D of t equals negative 3/4 t plus 27. What does d of t mean? Fancy way to say y. It's saying distance is a function of time. So number 3, function rule. Number 4, table of values. No, I'm not asking you to get crazy here. I don't care about a million points. Just give me 2 more points. 2 points that are different than the 2 that we started with. Where will I get those? From the table of values. But the function's not in there. The calculator told us the function, but we didn't enter it anywhere yet. So you're going to have to go to y equals and put in negative 3/4 x plus 27. Look at the table of values. Just give me 2 random points. For example, I see 821. Okay, so for number 4, I'm asking for a table of values. Just give me 2 points there. 821. What's another point you see? Now let's pick points that would make sense in this problem. Like, I don't really think negative points are going to make sense here. 424. 16, 15, and they don't have to be nice whole number points. I just like whole numbers. And I do want you don't have to write this part, but I want you to understand what it means. 821, what does that mean? Exactly. In 8 minutes, after driving for 8 minutes, he's 21 miles from home. What does 16:15 mean? After driving for 16 minutes, he is 15 miles from home. You can write on the paper. All right, now number 5 says, tell me what the slope is and its meaning. What is the slope? Negative 3/4. Please do not put an x in there or I will go crazy. Slope is just a number. Now what I do want is the units. Negative 3/4 what? Miles per minute. Slope should always have 2 words. Always. Dollars per hour. Miles per minute. Miles per gallon. Well, the word per is just the division sign. I'm saying it's got a y number and an x number. And the y number is miles. The x number is minutes. It's always the y's over the x's. Slope is always a rate. It should always have 2 words with it. Now, boys, you also have to write a sentence about what that means. Now, let me show you the 2 different ways you can write it. Why is it negative? Because what's happening to his distance from home? It's decreasing because he's driving towards home. So what does this slope mean? This is what I would want to say. It means his distance is decreasing. That's why it's negative. If it was positive, we would say his distance is increasing because he'd be driving away from home, but he's driving towards home. His distance is decreasing. Now listen at this part. At a rate of 3 miles every what? Every 4 minutes. That's one way to say it. It's not the only way to say it. But that kind of gives the meaning of each one of those numbers. Right, Kwong? Sit up, please. That means his distance is decreasing. That was the negative part. At a rate of 3 miles every 4 minutes. There's another way to say that. His distance is decreasing at a rate of 3. I'm going to replace this with something else. 3/4 of a mile every what? Minute. You could also say it that way. Either way is correct. 3/4 of a mile every minute that goes by, or 3 miles every 4 minutes. It's not 3 miles every minute. It's 3 miles every 4 minutes, or 3/4 of a mile every 1 minute. See what I'm saying? It's okay. You can either break it apart to where you describe what each number stands for. The 3 is the mile number and the 4 is the minute number. So you could break it down and tell me that it means his distance is decreasing because he's heading home. 3 miles every 4 minutes. So when 4 minutes go by, how much closer is he to home? 3 miles. When 8 minutes go by, he's 6 miles closer. See what I'm saying? Or you could describe it as this is the mile number altogether, the fraction. Negative 3/4 miles in 1 minute. That means the same thing. Okay, now number 6 says, tell me what the y-intercept is and what it means. So what would you put for number 6? What's the y-intercept? 27 what? Miles. Okay, it's 27 miles. And why is that significant? That's how far away he was when he started driving. That was the distance from home. And again, I really hate to say always, but y-intercepts are usually where something starts, and x-intercepts are usually where something ends. So this would be the distance from home before he started driving. Or you could say something like it's how far away the stadium was. Because he's leaving from a football stadium, isn't he? Or the distance from the football field. Alright, number 7. Now this one we don't know just from the equation. Number 7 says find the x-intercept with a rate and everything and tell me what it means in this problem. How do I find an x-intercept? You could do it manually by taking your equation, putting a 0 in, solving for x, or you could do it with the calculator. But you got to remember to put y equals 0. And you want to calculate where these two things do what? Intersect. And you're going to have to zoom out. If you're in Zoom 6, you're not going to see it. And mine was already zoomed out. And I'm trying to calculate where they intersect. What are y'all getting? 36 minutes. 36 minutes. Why is that significant? Right. That's how long until he got home. How do I know he's home? Because the miles is 0. The y values stand for the miles away from home. Well, at 36 minutes, he's 0 miles from home. That's hopefully where he's going to stop. All right, number 8. This is the one kids were afraid of, but it's not that big of a deal, and I want you to listen to the vocabulary I'm going to use here. Number 8, we're going to make a graph. We're going to put labels and units and everything. What do we want to call this graph? Let's give it a title. Trip home. Now, you have to label everything. What do our domain values stand for? Time. Specifically in minutes. Please hush. What do our range values stand for? Distance from home. Or you could just put distance. My D doesn't look very pretty. Specifically in what? Miles. And yes, I want the unit. Now, let's talk about our domain and range values. Because we've already figured out our domain and range for this situation. What do y'all want to talk about first, the domain or the range? The domain. Let's talk about the domain, which is the x values, which is the time values. What's the lowest time value that makes sense? 0. 0 is the lowest one. That's before he started driving. What's the highest time value that makes sense? 36, because that's when he got home. So our domain values go from 0 to 36. What do we want to count by? 6s? Wow, y'all are lazy. Okay, 6s. We can do that. 6, 12, 18, 24, 30, 36. You can write on this. This is like your notes. But now what I am showing you, this is exactly what I want to see for your homework, and you probably won't have space on this to do it. You'll have to give me another sheet of paper where you do Mr. Adams' situation. Now, let's talk about the range values. What's the lowest range value? 0. What's the highest range value that makes sense here? Boys, pay attention. 27, because that's as far away as he ever was from home. What do we want to count by then? 3 sounds good to me. 3, 6, 9, 12, 15, 18, 21, 24, 27. And we already know points. You got points from the T-chart. We got 2 of the most important points, which one of them was 0, 27, and one of them was 36, 0. Then what? Connect the dots. And there's your graph. We got labels, we've got units, we've got a title, we've got 2 points. Now, your homework is going to be to do the same situation for Mr. Adams. It's a very, very similar problem. It will have different values, though, because the numbers are different. But you got to explain what slope is with its rate and what it means, what y-intercept is with its word and what it means. Just the Mr. Adams. Now, you got to do all 9 things here for Mr. Oh, all 8 things here for Mr. Adams. All the stuff we just did, you're going to do again, except now you're going to do the Mr. Adams situation. Okay, now we are going to grade homework, and then we are going to talk about your quiz, and then you can start your homework on Mr. Adams.